We're going to start today by looking at a simple gear train. So what I have in front of you is a basic gear train, and as always, what you design and build is probably going to look a lot different. These are just some VEX IQ pieces. I built a simple base and mounted a pair of gears on them. So what is a gear train and what does it do? So a gear train is simply defined as any number of two or more gears that are intermeshed. That is, their teeth connect in some way. In this case, they connect right here. Now these gears are designed to work together. The pitch or angle of their teeth and the length of each tooth are designed to make them mesh properly, just like you see. And so with a gear train, when you spin one gear, the other one obviously moves in sync. Now, the big important piece about gear trains is something called a gear ratio. And a gear ratio is defined as the relationship between the driven gear and the drive gear. So in this case, if this is my drive gear, that is the gear that has power attached to it, a motor or somebody cranking it by hand, this becomes the first part of our gear ratio. So in order to figure out what that gear ratio is, there are a couple of ways to do it. Number one, you can count all the teeth on your gears and create a mathematical formula. So the number of teeth on the drive gear compared to the number of teeth on the driven gear. The other way to do it is to simply look at how many times each of them go around. So if I start spinning this gear, I'm going to watch this piece of plastic right here. You'll notice they start out aligned, and basically what I want to do is I want to see how many times can I spin this gear around and this gear until they line back up perfectly. So I come around here one time, they don't line up. Two times, they still don't. Three, then four, and then I come back, and on five, you'll notice they line up. So every 5 times that I spin this, they match back up. So what we have to know now is how many times did this one spin? Well, I'll spare you the going back and watching the video. This one spun 3 times. So the gear ratio for this particular set of gears, where the smaller gear is the drive gear, is 5 to 3. That is, for every 5 times this one spins 3 times. Now if you switch it up, for example, literally rotating it, and suddenly this large gear is our drive gear, and we were to spin it, you'll notice I can spin it once, twice, and 3 times until they match back up, and this one spun 5 times. So now our gear ratio, where the larger gear is the drive gear, is 5 to 3. So that tells you what the numbers are, but what do those really mean? Well, it all comes down to power versus speed. When we talk about power versus speed, we're talking about torque ratios and speed ratios. If I spin this one time, you'll notice that this one goes 1 and about 2/3 of a loop around. So this one spun more times than this one did. That means that this gear is rotating slightly faster than this gear. So this is a speed ratio. 3 to 5 is a speed ratio. It means that this gear is going faster than the original gear. Now, what does that mean in practicality? It means that if you put a motor on this gear and a wheel on this gear, every one time you spin this, the wheel's going to spin about 1 2/3 of the time, which means that this wheel is moving faster than your actual motor. So it creates a speed ratio where the result is faster moving than the input. Now, what about the other way around? So if we start off with a small gear as our drive gear and we start cranking it, you'll notice that for every one time I go around, I only move about 2/3 of the way around on my driven gear. So this is called a torque ratio. And what this is it creates more power. So the definition of power is force over distance. Basically, how much force are you applying over what distance? For this torque ratio, we're applying the same amount of force. So for example, I spin this, whatever power it takes me to run this, we're applying that over a longer distance, even though it doesn't look like it. So the more of a distance that we apply that power over, that force over, the more power this generates. You'll notice if you look at a giant crane that they use to build buildings, their motors are attached to small gears, and their actual lifting mechanism, so for example, the end of their crane is on a large gear, because that creates more power. It means that a smaller motor can lift a greater weight. And this is really good when you're building robots, because it means that a small drive motor can lift a lot of weight. But that's the basics of what a gear train does. It's just about transferring motion from one source to another, and you can use that relationship of either small to big being a torque or power ratio, or big to small being a speed ratio to increase speed, to control what your device is going to do.